All right, recording is rolling. It's Tuesday, October 31st. Ooh, spooky. I got a couple starter questions about throwing a ball straight up. How high does it go? We need to finish AP classroom. Got one question left on that front. We'll go through textbook puzzles. What do I do with the text? Oh, yeah, thank you. What do I do with textbook puzzles is show you guys how to set these up and solve these. And then give you guys tomorrow to actually work in teams and work independently. I mean, kind of the point of homework questions is you get independent practice, but I'll give you guys some time class tomorrow. A little bit different. Things a little bit different. Right? And then, okay, so tomorrow, let's look at tomorrow's schedule. You guys know we have slightly shortened classes. We got these 40-minute classes. You guys are going on period 1, period 2, then your homeroom class, which is new. Do you guys know through Focus where your homeroom class is?
No.
Right. So I think you check on Focus, right? Focus. Certified. Right. I know a bunch of not all you guys, but a bunch of you guys are in here. Yeah. All right. Then period 3. Then lunches with your 4th period teacher tomorrow, right? So you guys check with your 4th period teacher. All right. And then all right. Thursday we'll do this mechanical advantage lab with pulleys. Right, where's my pulleys poster? Is it not? Well, all right. This is okay. I've got this pulleys. No, whoops.
Levers.
All right, here we go. This is gonna be Thursday adventure right here. And so talk about it later. Okay. Best use of our time today. All right, throw a ball upward at I got 10 meters per second, and then later on we're gonna triple that speed to 30 meters per second. Oh yeah, go ahead. Yeah, 5 meters. 5 meters goes right. Right now, guys, if you triple the speed, what do you think happens to the maximum height? Times 9. All right, and then 5 meters times 9 is 45 meters. All right, you guys are on. You're on. All right. So here, I'll go through this a little bit fast. At this point in the year, you guys have at least 2 different ways you can solve this. If you go back real old school, you guys remember these 3 guys? Right. Now, which one is probably best at answering the question, how high does it go as a function of throwing speed? Yeah, the 3rd one, right? Alternatively, you could pick the middle one, solve for how much time it takes to get up there, and then plug that time up here, solve for max height. But you guys are right, the 3rd one can handle it all by itself. So we'll do that, and we'll switch over to the new way, conservation of energy. Right? So the old way was get a ball, throw it. I'll call this V naught, like the initial speed. It goes right, rise to some maximum height. Call this H max. Right? And what kinematic value aligns with maximum height? Oh yeah. Okay. And then what do you know about the speed up here?
0.
Yeah, 0 meters per second. Right? Yeah. So let's go. Final velocity squared equals initial velocity squared plus 2ax. Now that's straight off the formulas, right? We're going to modify this a little bit for this scenario. And so this is going to go to 0 meters per second square, whatever. Right? Coming from whatever the throwing speed is. Let's solve this in terms of variables. You're right. Yeah, this would be the gravity field. Also, if you throw it upwards, the gravity's pulling down. Maybe call this negative g. We're going to do this minus 2gh, right? So, and since this does go to 0, I'll call this max height. Right? I really want to know what's kind of the relationship between the throwing speed and the resulting maximum height. Right? So we can do this in terms of variables, right? Add this term over, divide by 2g. Right? So yeah, h max ends up being, well, we got the throw speed squared, then add that over, divide down. Right, like this, right? Which you guys have seen this before, right? You guys saw this probably back in like late August, September, somewhere thereabouts. Right? Right. So now we can plug in different values. I said 10 meters per second. Let's try 10 meters per second. H max equals to 10 meters per second. Square that, divided by 2 times 10 meters per second squared for gravity. Yeah, here, since I'm, well, the negatives already accounted for right here. Yeah, so it's what we do. Yeah. So so it's going to go the same direction that I'm throwing it. 100 divided by 20, it's like 5 meters, right? 5 meters high, right? Versus if you swap out the throwing speed with 3 times as much, 10 meters per second squared down here, right? It's at 900 divided by 20, which is 90 divided by 2. It's like 45 meters. There you go. Yeah. So Yeah, so you're right. 3 times the speed results in 9 times the height, right? Look at there, right? Now that's the old way of doing it. That's like back in like August, September timeframe. Let's switch over to the new way of doing it. I could call this, guys, what would be in the closed system? The ball and the earth, yeah. So I could call this the ball earth system to be a closed system. Right now, this is after you've thrown it. So like the nanosecond after it's released from your hand, right? That's the speed. So we're going to sum of energy at the bottom is equal to sum of energy at the top, or initial final, point A, point B. All right, what kind of energy initially? 1/2 mv squared. So not. And then what kind of energy at the very top? MGH. It's all MGH, right? And if we want the relationship between, say, how fast we throw and how high does it go, this would be the max height. That's what that would be. Okay. Ooh. In the kinematic version, I never mentioned the mass of the ball. Is that okay? Yeah. It doesn't matter. Right? Yeah. So we're solving for H max. Just very simply divide the G over, right? So H max is, I got the throw speed squared divided by, got the 2, got the G, right? And it's the exact same expression that we got before. Right? Throw speed squared divided by 2G, throw speed squared divided by 2G, right? There you go. And plugging the numbers together, obviously the same. Okay. All right, you guys get it? All right, there's a nice review. The old way of doing it, the new way of doing it, same answer. Let's switch over to AP Classroom, knock out that last one.